All right, guys, really quickly, we're going to finish up 13, 14, and 15. Now, these are different because now they've given us the expanded form. I like to refer this as summation notation, but it's expanded. So what we want to do is we want to condense this. We want to rewrite this using summation notation. So in other words, we want to have my sigma here showing that we are finding the sum of something, right? And I want to have n equals some value, my starting point, and then I want to have my ending value, up there at the top. But what I have to do, the hard part, is I have to look at this series here, that sequence, and I have to determine what the pattern is, right? How can I define what's going on? So here's what I notice, and guys, you get better with this with practice, and you do have this for homework, so it may take a couple times. But what I notice is that I have a 5 in my denominator, and it is not changing. So that 5 will probably stay down there, right? The only thing that's changing is my numerator. And what I notice is I have a 2, a 4, but then I have 8, 16, and 32. Okay, so what's happening there? So I can't say I'm multiplying by 2, or can I? Can I say 2 times 2 is 4, right? 4 times 2 is 8. So what if I say 2k? Or in this case, let's just see what happens. If I say 2n, where's my eraser? If I say that is an n, come on. I don't have time for you to be cutting up. 2n, and I let my n be equal to 1, and I don't know. We can just say 1, 2, 3, 4, 5, 5, right? So what does that give me? So that would give me, what am I doing? This would give me 2 times 1, which is 2, so that would give me 2/5, plus, and then 2 times 2, which is 4, so that gives me 4/5, and then 2 times, if n is equal to 3, that would give me 6/5. That doesn't work, right? So I can't do that. So it's okay to play with these sometimes if you need to. So that don't work. So let me back up. And I do know what the answer is. I'm just trying to get you to see that we can reason with ourselves with these. We can check ourselves. So that 5 is, again, going to stay there. But what happens if I do 2 to the, I want to say k. I don't know why I want to use k. But we're using an n. I put n for this. And let's say we have 1, 2, 3, 4, 5. Because it's changing by 2. I know that we're changing by 2, and multiplying by 2n did not work. So what about 2 to the power of n? Because these look like products of base 2 for me. So what I have there, if I substitute 1 in, I have 2 to the 5th power. If I substitute 2, 2 squared gives me 4. If I substitute 3, 2 to the 3rd power is 8. And 2 to the 4th power is 16. And 2 to the 5th. So that works for me. So this, guys, would be our answer. That is writing that sequence there in summation notation. So we're going to use that same idea for number 14. I'm going to erase some of this so it looks a little bit neater. I don't need all of this. So if I look at 14, so what we're looking for, it might be better for me to say at this point now, that what we want to look for is a base, right? So if I can find a base raised to some power that produces these patterns, that's what we're looking for. That's what I need to find. So when I look at 14, again, I think of base 2. I think of using a base of 2. So I'm going to write my sigma symbol here, and I'm going to go ahead and put my base of 2. And there's a few different ways we can write this. So when I look at this, I see 2 maybe I could use 2n, okay? But then in this case, maybe I want my n to start at -1, and I could end at, if that's -1, 0, 1, 2, 3. So that might give me, so does that work? So let me check it. That would give me 2 to the -1st power. Then that would give me 2 to the 0 power, 2 to the 1st power. Yes, because 2 to the, and I'm running out of room. I can't really write over here on the side. But this would give me 1/2 plus 1 plus 2. So that pattern does seem to work. I think that's going to be fine. I may want to come back to that one. I am not sure if they want us to use a negative number, but let me finish that, and I will leave that the way that is, and I will come back to 14 just to be sure. But 15, we have the same idea. So when I look at this for number 15, what I immediately notice here is that I have a negative and a positive, a negative and a positive. And what I also immediately notice is that 2/3 seems to be the base here. I know that 2/3 to the 1st power is 2/3. If I square 2/3, I get 4/9. If I cube it, I get 8/27. So the only thing I have to remember there is that my sign is changing. And if you go up there back in our notes, we discussed what happens or what causes that sign to change. So my sign here, let me go ahead and write my sigma notation. For me, what I would start with, and I want you to understand that there's a few different ways that that we can do this. We can write these different ways, but I personally would begin, and I would write this using a -2/3, and I would write this to the nth power. And I know what happens as that n changes. As I go from an even n to an odd n, my outcome is going to be positive and negative. So that causes that sign to change. So now I have to ask myself, where do I need to start so that my first term is -2/3, and this last term is a positive 16/81. So I know that if I start with 1, my outcome will be that -2/3. So this would be n equals 1, maybe n equals 2 would cause me to have a positive, so that works. N equals 3, again, an odd exponent would give me that negative. And then I would end at 4. And that would be it. So you guys, if you have any questions, do not hesitate to reach out. I'll be happy to help.